Ladies and gentlemen, welcome back. It gives me enormous pleasure to introduce what's called a press point, but there's enough of you to make it a press conference, so let me moderate it again. It's called Mining the Moon, and it's generally concerns the Google X Prize, and there are three speakers. I will leave it to Anita to introduce herself and the general theme of the conference, and then the other two speakers, and I'll look after the questions later. Thanks very much.
Thanks, Tim. I'm Anita Hewitt.
Push the button, please.
Sorry?
The button.
Oh, yes, sorry.
There we go. Lovely. Okay, I'm Anita Hewitt. I work for X Prize, which is a foundation that, not-for-profit foundation that encourages technological breakthroughs for mankind through incentivized competition. We organised our first prize, the Ansari X Prize, which was won 10 years ago this year. And 10 years down the line, we are now seeing the industry from that. The prize was for launching the first commercial vehicle that could carry 3 people into space. 10 years down the line, we're now seeing an industry built up that's worth billions. We have Dragon X going up to the International Space Station to deliver supplies. Towards the end of the year, we have Virgin Galactic starting its commercial flights. So the prize that I work for is the Google Lunar X Prize. We're sponsored by Google, who have put up the very generous $30 million purse for the competition. And we have 18 competitors in the competition from around the world. We have competitors from North America, South America, Europe, and Asia, so we really span the globe. And all of these teams are striving to become the first commercial entity to land a robot on the moon. Their robot has to travel 500 meters, so it has to explore on the moon, and it can do that any way it likes. It can hop, it can drive, it can roll, it can burrow underneath if it so chooses, but they have to travel 500 meters, and then they have to send back high-definition imagery and video. And they have to do all that by the end of 2015. So the first prize is $20 million. There's a second prize of $5 million. And then there are various other bonus prizes for demonstrating technology on Earth to show that they can do it. And Robert from the Part-Time Scientists is the leader of one of those teams that's doing that at the moment. But the reason that we're here, the reason that we've organised the session today is to get the conversation going about mining the moon. Get the conversation going about why we want to go back to the moon, what could we do there, and say that, you know, as with the Ansari X Prize, within 10 years this should, we expect it to be happening. So we have Bernard Huang from the European Space Agency. He was the lead project scientist for the Smart 1 mission, which mapped the moon, Europe's first mission to the moon, back in 2005, was it, Bernard?
We launched in 2003. It took us 18 months to arrive there. We got in the Guinness Book of Records for the slowest mission to the moon. But it took only 60 liters of fuel. So we make good use of Earth's resources to go there.
And you're also the executive director of the International Lunar Exploration Working Group.
Yes, so that's a forum that reports to COSPAR, the Committee for Space Research, but that is sponsored by space agencies from all over the world, but also other stakeholders of exploration, so commercial, academic, public, overall age.
So Bernard's going to talk to us about why we want to go back to the moon, and then Robert is going to talk a bit about how the Part-Time Scientists and other commercial organisations are looking at making that a practical reality.
Yeah, so thank you very much, Anita and team. So it's a pleasure to be here. So welcome to the moon. Why do we want to go to the moon? Fasten your seatbelt, because we are going de facto. We have been there 10 years ago. We launched in Europe a mission that went to the moon, Smart 1. We are now celebrating the 10 years after. We were just on our way still at that time. And we have discovered a new moon. A new moon, and you could say that we have to mine. We have to mine the moon, the resources on the moon. This is also, here you can see illustrated a study that we have performed, we have performed that at ESA together with some industry and some innovative architects as well, how we could use the local resources to sustain an habitat on the moon, to live off the land, making a very good use on the place of the lunar soil, by even 3D printing a lunar habitat to complete some modules that we would bring from the Earth. But there are also many other things we can mine on the moon. Even now to start to mine the moon for what is the simplest to transport. Things that have no mass, photons, information, energy, solar power. And that's what we are starting now to do, to mine the moon for data. Data that we have obtained with our Smart 1 mission, but that was followed by a fleet of orbiters with even better instruments. Europe has contributed to an orbiter that was built by India, Chandrayaan-1, and we put 3 instruments also on this mission a few years after Smart 1. We contributed also to support our Chinese colleagues that launched 3 missions to the moon, 2 orbiters, and even a last lander that landed in December, just 2013, a few months ago, and that is still operating. We have a communication infrastructure, our ground station from the European Space Agency that helped China in critical phases, but also to get more data. But we realize also, even with our little technology mission that was funded mostly to develop new technologies for the future, that there is a lot of knowledge on the moon we can mine. Knowledge about ourselves. We don't know even how the moon was formed. We thought, and I think it's still the consensus among scientists, that the moon is a daughter of the Earth. It was formed 4.5 billion years ago, when the Earth was maybe only 50 or 100 million years. So only maybe 1 or 2% of its current age. The Earth was impacted by an embryo of a planet. And from this, we had a debris of disk from which the moon formed. So the moon is the daughter of the Earth. Now, when you analyze in detail the data from samples and from remote sensing, like from Smart 1 and other missions, we found out that it doesn't really stick together, this scenario. It's a bit more complicated. And now we have new theories where maybe the moon was formed when 2 half-Earths were impacted each other. And then this created enough debris to form the moon. Or with the Earth that was spinning so fast, almost at the limit of ejecting of virgin material. So we are still working out a detailed scenario, how the moon was formed, what was the status of the Earth, because, of course, depending on what happened then, the conditions on the early Earth were different. We also use the moon to understand what happened to the Earth after. In particular, we look at the phase of the moon that is discovered by craters to understand how the Earth itself was bombarded. And in particular, at the time when life emerged on the Earth, there was a giant bombardment. Did that sterilize life? Did that provide opportunities for life? Did that bring materials for life? We need to still study that on the moon. And the new discoveries that we have made now, not only studying processes that work on the moon, like volcanism, rainfall on the moon, we found also there are some volatiles on the moon, some ice in the polar regions. And this shows that there is some delivery of this ice and even organic molecules on the moon, like there was on the surface of the Earth. So some of the ingredients for life that were brought to the Earth, we can find them in polar regions of the moon. So that's how there is a lot of knowledge to mine on the moon. The next step is also to see how we could better understand resources that are there, to use them in situ. There are some minerals containing oxygen, containing iron, containing rare metals. There is also some helium-3, some isotope of helium that could be, in 40, 50 years, used for clean nuclear fission. And a cargo of 10 tons of helium-3 could provide the energy for Europe for 1 year. So, you know, one of these modules, you fill it with helium-3, bring it back, you have energy for Europe. But it's in very small quantities. So it will take some time before we would process all the soil to remove some of this helium-3. Before that, we can use the material in situ. And we need also to develop some clever, smart technologies with some robotic precursors that can analyze how we could harvest in situ this material. Also, how we could extract the hydrogen, the water from there that could be used in situ. And this together with technologies of recycling that we, for instance, we use on the International Space Station or in extreme habitat on the Earth, we could live in a sustainable way on the base. Now, the moon is also a great mining ground for humans to work together. You know, if you work in a mine now, you need really a big dedicated team. Now we have international teams that are deploying assets all over, and the Google and X Prize are going to contribute a number of these landers, rovers, so we see there will be a robotic village soon. A great opportunity to work together peacefully, exploring the moon to the benefit of mankind, but also exploring modes to work together between governments, so the commercial, innovation spheres, academia, young lunar explorers. I see some in the room as well. So those are going to live there. So having all stakeholders that can be part of this future preparation for the International Lunar Base, that will be also an opportunity for us, putting our civilization a bit outside the Earth. And that's another aspect I would like to mention. The moon can be also mined as a platform to inspire the youngsters. Some of them are involved in this Google Lunar X Prize. They are so imaginative. I'm very amazed, and I would like to be one of them. Maybe when I retire, I join the young part-time scientist. And also the moon for mining, innovation, also inspiring young people to create their jobs, to do things, also created jobs for our own economy. And we discussed later how this can be, the moon can be a platform where we can have some challenges we sort out, and we can use also for our Earth, which is, in any case, the mother of the moon. So you know, the Earth moon is just a double planet system. So the moon is like the 8th continent of the Earth. So it's only natural that we think to mine it for all resources, material resources, but also this intellectual challenge of developing projects already now with data, with robotic precursor missions, but also with preparing for humans and preparing to use resources there for beyond and for us.
Thank you very much.
You. Mm-hmm.
And Robert.
Okay. Hello, I'm Robert from the Berlin-based team Part-Time Scientists participating in the Google Lunar X Prize. We're a team based in Berlin, Germany, but we're also centered around in Austria. And we're actually an international team, so we have participants from not just out from Europe, but we're mostly in Europe, but also from the US. And we are one of the 18 teams participating in the competition. And you have to understand one thing about the competition itself. It was launched in 2007, and we were really one of the teams who joined really late in the game. And I think we joined in the very last call in 2009. And the motivation that I saw when I founded the team back in 2009 was that I saw that we had very good efforts when it came to research in space, but I saw the same situation that the supporters from Google saw when they funded the Google Lunar X Prize, is that there is no lasting commercial access to space. So the point is so that they're really having the ability to go to, for example, bring something to the moon just based on a commercial value, not just for one research mission, but for example, if just a normal company wants to employ something on the moon, that they can, for example, do it. And looking at ways how to do this was actually what got us started. So what we want to do as the part-time scientist is to establish a layer of technology where future space exploration becomes much more easier and cheaper. So this is mostly based out of nothing really surprising. It's mostly based out of commercial off-the-shelf technology. So taking normal technology, or in some small parts even technology that are right out of the lab, and trying to modify them in a way that they help us get to space with, for example, lighter spacecraft. To be a little bit detailed, for example, In our case, specific case for our mission, we really want to use, for example, smaller launch vehicles and more lightweight landing modules. So because really everything that deals with cost in space comes down to mass. And our goal in this case is to make it possible to utilize the resources that there are on the moon. So for example, to be practical, in our rover, which is called Asimov, has a camera system mounted on top of it, which is pretty similar to the MAST camera that you have on the Mars Science Laboratory. And if you know the MAST camera, then you know that has a set of filter wheels which enable it to analyze the surface structure. And in our case, we have 9 filters mounted with a spectrometer and some other scientific instruments to learn more about the surface area of the moon. And then we're having features, for example, like real-time autonomy, which makes it possible that the rover can quickly explore unknown terrain areas. So we can drop it in a certain area and say, okay, just explore this area and map everything out that could be interesting. And this helps us to see if there are, for example, resources worth mining. And for example, there's of course always the aspect of mining something and bringing it back to Earth, but then we have to be really precious. So from I don't know, from a monetary point of view, because bringing something back to Earth is in this case would be really expensive. But what I personally see, what I think is really important and exciting is to use the resources right there on the moon. So as we already heard, the moon really has the capability to help us reach out into space further and use itself as a baseline for future space missions. So a lot of people always think about getting to Mars, and I think this is an exciting subject, but I think we should get to the moon first and use the moon as a stepping stone into space. And from our mission point of view, we've planned for the Google Lunar X Prize one mission before the end of 2015, which is a lander mission based 2 rovers, 2 robots, 2 rovers which are going, one rover is going specifically for the GLXP goals, and another one is testing out some certain technology that we want to do in regards of 3D printing on a lunar surface, for example. And then we got 2 subsequent missions. So actually we have 3 missions planned for a time frame of about 5 years. And we want to use the hardware that these missions bring to the moon and that other teams, for example, that on the Google Lunar X Prize bring to the moon, to really, as I said, as a layer of technology for future missions. So, for example, we're using laser-based communication terminals, which in itself are nothing really special. But the point is that putting this on a lander that you put constantly on a lunar surface enables others to also utilize this as a communication relay, for example. And this makes it a little bit easier because communication is also one of the, there's a whole lot of challenges when you do something with space. And for example, helping others doing certain things easier, for example, making it easier to do communications can help them get their costs down and do more, for example, with their money, or not do more with their mission. And yeah, I think this is what I think is exciting and what drives us. And yeah, a question that we always get asked is that really is a good number of our team is doing this part-time, but also we got some members of doing this full-time. And yeah, we're really excited about the opportunities that space is giving us and that the Google Lunar X Prize is providing in this case.
Thank you very much. Right. If there are questions, would you please wait for a microphone, and would you please say who you are, because this is being recorded for posterity, and there's a questioner over there. And by the way, this is supposed to be a half-hour press conference, but I've arbitrarily extended it to the 45 minutes because I feel that there's quite a lot of questions to ask.
Thanks. This is Alexandra Witsi with Nature. My question is for Bernard. What's next up for ESA in terms of lunar exploration? What's on the near-term agenda, maybe cooperation with China or elsewhere? What is ESA's next steps?
Well, next step, we are still working hard on the data that we have obtained with the different missions to work out the analysis of the science and the preparation for the future we can learn from this data. We have approved also a mission together with the US where Europe is going to build the service module that can bring the Orion capsule, this new capsule that can bring 4 crew. We have a special module using technologies that were developed for the automated transfer vehicle, so-called ATV, the cargo vehicle that go to the International Space Station, one of the most sophisticated platforms we have built. We are going to adapt it to put it with Orion capsule, and this can bring 4 astronauts around the moon or even beyond and back. So that's a big contribution now that has been approved as a barter contribution to the operation of the International Space Station. The first launch is planned in 2017 already, in an automatic mode, where you will have this deep mission. We will check that everything works well. And then there is in discussion how in 2020 there will be a crewed expedition. We call it Exploration Mission 1, where this could go around the moon, even beyond the moon, so even go further than the Apollo astronaut went, so maybe a bit on the far side, but still bring back the astronaut. And so that's already quite a large amount of effort. Now, as you mentioned, with China, we have provided communication, so infrastructure communication in critical phases for our Chinese colleagues. And now, still, while the Chang'e 3 lander and the U2 rover are still sending data, we are helping our Chinese colleagues to get some of this data. So now, as you have, there are a number of other opportunities that exist in the world. That there are some countries, like Russia is developing, for instance, a set of missions going to the moon in 2017 and 2019, the pole of the moon, and looking at a sample return mission. There are also other countries like Japan preparing a mission to the surface of the moon. India is also looking at a follow-up to their Chandrayaan-1 mission. So what we are doing at the moment at ESA, we are developing some industrial activities to make us able to contribute to some of these international lunar exploration programs. So it's still in study phase. It's not fully approved for a mission. But for instance, we have some skills in Europe we can use. We had some scientists and instrument builders that were involved in SMART 1 and other missions, planetary missions. They would be ready to put instruments on various lander platforms. We have also a good knowledge of the technology of navigation and precise landing that we could contribute, because now the next step will be to land in an accurate position so that we could go, for instance, to explore some areas where we could search for ice and organics. We are also developing some work with some communication infrastructure we could develop further. And we have also some instruments like the one we developed for the Rosetta mission or for ExoMars, or Mars Robotic Exploration Program that is done now with Russia. We have the possibility to drill below the surface. And so this type of technology we developed now, this could be put on board of some of these international opportunities to prepare the next step.
Thank you very much. Kai?
Yes. Now, this project...
tell people who you are.
Oh, I'm sorry. My name is Kai Sempler. I work for the Swedish technical news magazine Ny Teknik. We have met before.
Yeah, Europa åker till månen.
Oh, yes, oh, yes. But this sounds to me a bit like going to Svalbard 100 years ago, or going to Antarctica or something like that. Is there any legislation that makes problems for you? I mean, can anyone do exactly what one wants to do on the moon? Because, I mean, in a way, 100 years ago, they could do that in Svalbard. But then just 10 years later, there was a big conference. And now it's quite regulated.
Yeah, we have a strong regulation, which is so-called the Outer Space Treaty, which is, in fact, a real treaty which has been endorsed by most countries on this earth. And this is regulating most of the aspects of activities in low Earth orbit, but even in deep space. And so this treaty stipulates that nobody, no country, no individuals own the moon. There are also a set of dispositions to protect the environment of the outer space. And this, for instance, there are some regulations on how to protect the life that you send there. In the case of the moon, there is a special category because there is no indigenous life we have found. So it's not so many restrictions as, for instance, the exploration of Mars. which could contain life, so you don't want to contaminate Mars, or other bodies that contain subsurface water and organics. So there is the COSPAR, the Committee for Space Research, to which actually IRWIG report is, in fact, the curator of these rules of planetary protection that takes into account the latest scientific knowledge that we have. For instance, now we found ice, possibly organics on the moon. What are we going to do? We should not drink it all. First, no. This water and organics may contain also cyanhydric acid and a lot of this compound you find in comet, sulfur. So I will not drink it. You just filter it before. But also you don't want to ruin this beautiful history of the solar system. You know, you have comets putting layer after layer each time they impacted the moon. Some beautiful information about the delivery of organics and ice. So you don't want to spoil that. So
that's a moon environment. But
you need to protect this.
Weapons on the moon for the Svalbard Treaty, for example, there's absolutely no weapons, no military installations on Svalbard.
The Outer Space Treaty also stipulates that there can be no weapons in space. Now you have to put the tools.
That there is actually there is a treaty that says that no weapons in space. When was it signed?
Well, it was part out of the Outer Space Treaty. But now the point.
Which year?
Our Outer Space Treaty was developed soon after the Space Treaty, endorsed by all countries in '67. So
67. All right. I'm satisfied.
It's a long time ago.
Yeah. But now, treaty is good.
I was a little kid then.
Yeah. But you need also to enforce.
I forgot it.
You need to enforce that the things are well followed up. Yeah. Yes.
Right. Good. Oh, good. Another question.
So I'm Frank Grotelüschen for German National Radio. So what about the plans of mining things from the moon, of some economical impacts? So are there any studies or things like that which say whether it will be reasonable to mine, for instance, helium-3 from the moon and bring it back to the Earth? So did some estimations about this?
Yeah, so as we started, just to send an instrument with a camera that sends you images of the moon, you bring back the photons for free and you can sell these images. So that's already a product that will generate revenue. Now with the Google Lunar X Prize team, they are going to do even better than that. Not only images, they are going to share with you an experience of seeing this robot alive there. And this also will generate revenues. Now, going there, you have resources. You have soil, very special soil. It's broken up, but it contains glasses, so you can build habitat like we used to do in the desert to protect yourself. This soil also is enriched with iron. And for instance, if you would put this soil in a microwave, all this iron droplet can melt, and you can make a concrete slab out of such dust material. With this, you can build on the place. This soil contains oxygen, so you are looking at ways to extract the oxygen. It requires a bit of power, but you have a lot of solar power there. You could build solar panels also there. So really there we are also looking at manufacturing there. So you can manufacture your big house, like we have tested, but I think that we can also manufacture a very small product there and bring eventually very tiny product, and this could be eventually, I think, a good lucrative market because it should be small. Now there are some rare elements also on the surface of the moon, and you could think to work out the market. I believe that the market will be more interesting as a triangular market. Like we had triangular market, you had spices in one island, you had the chocolate in another island, and you were selling the spices. And here the huge market is to, for instance, use some of this ice and organics in places where we don't have it. And there are some places in the solar system we don't have it, like in orbit. So you could import this on orbital infrastructure, space stations, and then you could very easily, from the moon, which is, you know, the gravity of the moon is 1/6 of the Earth, but the energy you need to leave the moon is about 40 times less than the one you need to leave the Earth. So to bring something from the moon to an orbital infrastructure is much cheaper. Also, you could, say in the long term, make use of launch from the moon. We spend so much energy and fuel just to leave the Earth. And so from there, you could have a new spaceport, and it will be much more efficient hub for going in any destination in the solar system, making use also some of these resources for fuel. And in the long term, we have the helium-3, as we mentioned, for energy.
Clive.
Clive Cookson from the Financial Times. I'd like to ask Robert for much more details about this as an example of the projects. Like, what's your rover going to do? How much should it cost?
Okay.
How is it? Who's launching it? All that sort of stuff, which, unless I've missed it, we haven't heard any of the details, which brings it to life. So we've been talking very interesting generalities about what might happen on the moon in the long-term future, but I'm more interested in what's about to happen next year.
Yeah, I'm a big fan of details due to being an engineer. So what I can contribute to the maybe the previous two questions, because I wanted to add it to the question regarding the regulations. There's also one thing which is called the Lunar Heritage Guidelines towards protecting lunar heritage sites. And this is important, at least for our team. I don't know if it's relevant for another GLXP team, because we are going towards the Taurus Littoral region, which is the landing site of Apollo 17. And we're going towards this region for two reasons, which are really relevant for our mission. For once, because it's one of the most well-documented landing sites, and we really know a great deal about the geological area, so we know that our rovers and the lander can touch down safely. And the second thing is that we want to, as best as possible, analyze what is left over of the lunar roving vehicle from the Apollo missions. The reason for this is there's actually a good document published by NASA about this. I don't know if it was published by NASA, but from people who work for NASA. And it details the compositions where this lunar roving vehicle is made out of, and it's made out of pretty various composite parts. And it's very, very exciting to see how this vehicle and these parts behaved of 43 years being on the surface of the moon with absolutely zero protection. And this is something that we really want to understand, because it helps a whole lot for future exploration and building things that last on the moon. Because that is something important. You can't just send one lander there and have it being a communication relay when it breaks down after 6 months. So that's the point, because this is what justifies the mission costs, operating for a longer period or on the surface of the moon. So, and for the rover, regarding the on-surface exploration, so where do I start? So the general mission design is that we have a mission which aims to start with a satellite carrier, which is important. So it's more like a small size mission. It's below 4 tons, which means that in our class we've selected the Dnieper, the Russian Dnieper rocket, as a launch vehicle. It's one of these former ICBMs that has been redesigned to be a satellite launch vehicle. And the good thing about it is that it's relatively cheap and well proven. It's a very rough kind of launch vehicle from the forces that is being applied to your mission. But for us, it was what won the evaluation of being the most cost-efficient way to get into space. And then we have a 2-stage spacecraft, which is what everybody calls the lander. In our case, it's made up of a landing module and service module. The landing module is on the top side, the service module on the bottom side. And this is what does the TLI, the translunar injection, getting us all the way to the moon. Then we get rid of the service module, which is something that you have to do carefully, otherwise, because it comes down on a certain place off the moon. And the lander is really a soft lander, which is designed to drop 2 rovers, which have a budget, a mass budget of 50 kilograms, but currently the design mass is just 45. And each of the rovers, and I think this is important to point out, has 2 drop containers. And one drop container contains a 5 kilogram payload, which is a CubeSat style hardware unit, which makes it easy to add scientific components to this mission. So I think this is really important. So for example, one payload that we have from our end. There's one payload that is reserved to the Google Lunar X Prize purposes. And one payload that we have, for example, on our end is a 3D printing test unit. It's basically a laser melting device where we want to evaluate how we can refine the lunar soil, because that is actually the hardest thing, refining this stuff in a way that you can use it for laser melting, and then trying to manufacture a very small part. It's more like a technology demonstration, but we really want to show that it works. That's the point. So that is, for example, one of these payloads. And of course, then there are these two rovers, which I already explained, with these cameras, which not just normal cameras, but really are scientific instruments capable of analyzing the surface area in a way that you can actually see if there is something of value that needs to be, for example, could be interesting to take back to Earth in future missions. So, and for example, to add towards this the GLXP value, I know for a fact that at least one other GLXP team is aiming to build just landers. I think it's called Moon Express. And they have, for their second mission plan, to have a sample return mission, which is solely dedicated to get lunar soil material back to Earth, because they believe they can evaluate it much better here on Earth than they can do it on the Moon.
Sorry.
Sorry.
Obviously, no one's won the prize, so you're having
Of course.
to pay for it yourselves.
Yeah, so our goal is to get the mission costs, keep them below 50 million euros.
50 million.
50 million, below.
Who's paying for that?
What we currently have is that we have I think you can call it consortium. So we're having currently a lineup of 50 companies that support our efforts. And yeah, this is really, it's a good range of, they're actually not so much of the aerospace industry, but mostly of the normal everyday industries that you have. That have some interest or the other to getting their technology tested in space or contributing to maybe future market opportunities in space. Yeah, and for us it's actually interesting to see if there is a symbiosis, for example. If a company has a product today which could be, for example, which could be modified to be used in space and which could benefit other missions, for example.
No, it's true that we have to broaden space. We have an example for Smart One. Our communication system on board was inspired from the automotive industry. So we use this solution, which was all tested, we adapted it to space. So there are a number of industries which are not the traditional space player, but they should have an opportunity also to join in, contribute. And so Google Lunar X Prize may be also a nice way for them to come in.
Thanks. Franz Zeller, Austrian Broadcasting Corporation. Google is spending $30 million. I mean, that's equivalent to me giving my kids money to buy ice cream. But still, it's $30 million, which is quite a lot of money. Which rights do you reserve as Google? What do you get back from the whole mission, apart from PR?
Okay, so there are two things here. I mean, Google as the sponsor has chosen to support the competition with the aim, really, as Bernard was talking about earlier, for inspiring a new generation of scientists, software engineers, the people that they need to work in Google for the future. With regards to what rights we withhold, we have rights on the broadcasts of the mooncasts of the data and imagery that come back from the spacecraft that they have to send to us. I think there's 8 minutes in total that they need to send, and we have proprietary rights over that, and there are certain media rights over testings and other activities that you will be doing. So it is generally media activities. The idea is to build a new space industry, and so therefore we want to make sure that the teams have the capacity at the end of this to commercialise their activities. You know, we don't want to go to the moon, or X Prize certainly doesn't want to go to the moon itself. We want to be there to support the teams in their long term.
But you don't get any rights on certain processes being applied or on any new inventions.
No.
So we have Google Moonview perhaps afterwards.
That's up to Google.
I think Robert has something to add to this.
Yeah, I think it would be a very good example to look at the Ansari Prize in this case, because you know you had the Ansari Prize, which was won by a team which later became Virgin Galactics. And if you just look at Virgin Galactic today, there is no association between Virgin Galactic and the Ansari Foundation. And I don't think there will be any association between Google and the winner of the Google Lunar X Prize.
On that complex point, I think I'm going to bring the press conference to a close. I know the speakers will be available in the overflow room afterwards for a short time. I know that you could even go to the session that they're about to host at 4 o'clock?
Yeah, 4:30.
Yeah. And hear all of this again in much more detail. Thank you for your questions, and thank our audience, our panel too.